We'll next ask whether there's an easier way to find that break-even price than to just experiment and see where the magenta and the green areas are equal to one another. To do this, we'll introduce a new cost curve that's also derived from the total cost curve which we initially derived in panel E of graph 11.10. In particular, this new cost curve is the average cost curve, and it's simply the total cost that we illustrated in panel E of graph 11.10 divided by output. Because our production frontier assumes that initially it becomes easier and easier to produce and eventually it becomes harder and harder, it makes sense that this average cost curve would have a U shape just like the marginal cost curve does. If hiring labor is the only cost that I incur in production, then it has to be that the marginal cost of the first unit I produce is the same as the average cost of the first unit. If, for instance, the first unit costs me $10 in labor costs to produce, then the marginal cost of the first unit was $10. My total cost was also $10, and since I'm producing only one, that implies that my total cost divided by 1 is equal to the average cost, which is equal to $10. The average and marginal cost curves therefore begin at roughly the same point. In addition, the only way an average cost can fall is if the marginal cost lies below the average cost. This should make sense to you if you think about, for example, your grades. If you go into an exam with an average grade of an 80, and your average falls as a result of the exam, it must have been that your marginal exam grade was below 80. The only way it can drag down the average is if the marginal exam grade is below the average. For the same reason, the only way that the average cost can fall is if the marginal cost is below the average cost. So we know that so long as the average cost is declining, the marginal cost lies below the average cost. For the same reason, the only way the average cost can be increasing is if the marginal cost lies above the average cost. Again, think of a grade example. The only way your average grade can be brought up by an exam is if the marginal exam grade lies above your average going into the exam. For the same reason, the marginal cost must lie above the average cost when the average cost is rising. Now, if the only way that the average cost can fall is for the marginal cost to lie below the average cost, and the only way that the average cost can rise is if the marginal cost lies above the average cost, then this logically implies that the marginal cost must cross the average cost curve at the lowest point of the average cost curve. It is therefore no accident that in this graph, point D occurs at the lowest point of the average cost curve and at the same time is the intersection point of the marginal and the average cost curves. You can furthermore see that that intersection point of the marginal and average cost curves must lie at the height of P star. At P star, I produce XD, which means my total revenues are price times quantity, or P star times XD, the shaded area. One way of expressing my costs is as average cost times output. If I produce XD, my average cost can be read off of the magenta average cost curve, and it's equal to P star. So my average cost is P star, which means my total cost is P star times XD, the same shaded area. Total revenue minus total cost is therefore equal to 0 at the intersection point of the marginal and average cost curves, which means that that intersection point must be happening at the break-even price P star. If the price goes to P prime, on the other hand, I'll produce along the marginal cost curve, which we showed in panel A is equal to my supply curve above the break-even price. That implies that my total revenues will be equal to P prime times X prime, or the shaded blue area. When I produce X prime, I can again read my average cost off of the average cost curve, which in this case becomes AC prime. My total cost is average cost times output, AC prime times X prime, which gives us the darker shaded area. Thus my total revenue minus my total costs when price is P prime and I produce X prime is the light shaded area that remains. In other words, as price goes above the break-even price, I will produce more and earn positive profit.